Hi, I am Rahul. Welcome to my mathematics channel where you will get 100% guarantee of the knowledge. In this video, we study the matrix multiplication, one of the simplest method. If you follow this method, I assure that you will get the correct answer. Now first of all, we study how to do the matrix multiplication of these two. And if you do the matrix multiplication of these two, we get a diagonal matrix. So in this video we study why such a resultant we will get. If we do the matrix multiplication of such a two matrices, we will get 2 by 2 matrices, and if we interchange the order of these matrices, what will be the resultant we will study in this video, whether it is the same of the previous one or a different. So if we interchange the order of such a matrices, and if we do the matrix multiplication, we get a resultant matrix with the values -2, -6, 1, 22, 17, 17, 8, 3, 8. So if you observe, if you interchange the position of an matrices, the resultant matrices are different. So this is what we study, and the most important part we will study at the end of this video, why the matrix multiplication of such a two matrices is not possible. So I am assured that you will get 100% knowledge about the matrix multiplication. So let's start. First of all, we write the two matrices with space between the two matrices is the main key of this method. So first of all, we write the first row in between this. So 1 minus 1 2. We multiply this first row of a first matrices with the first column of the second matrices. So 1 into 0 we get 0, minus 1 into minus 11 we get plus 11, 2 into 0 we get 0. So this is how we multiply the first row with the first column of the second matrices. Now we multiply with the second column. 1 into 3 we get 3, minus 1 into 1 we get minus 1, 2 into minus 1 we get minus 2. So hope you understand. Now what will be the next step? Yes, you are right, we multiply with the third column. So 1 into 2 is 2, minus 1 into 8 is minus 8, 2 into 3 is 6. So this is how we multiply the first row with the each column of the second matrices. Now any guess about the next step? Yes, you are right. Now we consider the second row, that is 3 0 minus 2. Now we multiply 3 with the 0, 0 with the minus 11 and minus 2 with the 0, means we multiply the first row with the first column. So we get 0 plus 0 plus 0. Now any guess about this? Yes, you are right. Now we multiply with the second column. 3 into 3 we get 9, 0 into 1 we get 0, minus 2 into minus 1 we get 2. So hope you understand. Now the last is nothing but we have to multiply with the last column, that is 3 into 2 is 6, 0 into 8 is 0, minus 2 into 3 is minus 6. So now we multiply with the second row. Now we are left with the third row. So we write third row 1 0 3. We multiply 1 with the 0, we get 0. Now we multiply 0 with the minus 11, we get 0. And we multiply 3 with the 0, we get 0. Now we multiply with the second column. So we get 1 into 3, 3. 0 into 1 we get 0, and 3 into minus 1 we get minus 3. So obviously the last is nothing but how we have to multiply with the last column. So we multiply 1 with the 2, 0 with the 8 and 3 with the 3. So 1 with the 2 we get 2, 0 with the 8 we get 0, and 3 with the 3 we get 9. So this is what our resultant. See how the simple method is. It is, I assure that there is no any single mistake you did when you solve with this method. So now the resultant matrix is 11, 0 and 0. So only we simplify these entries. Now for the second row, we get 0, 11 and 0. So this is what our resultant, and for the last row we get 0, 0 and 11. So if we observe, our resultant matrices is nothing but a diagonal matrix with some diagonal entries as 11. So what is the reason behind such a kind of resultant if we do the matrix multiplication of such a 3 by 3 matrices? Is there any relation between these two matrices? Yes, if you multiply any matrix with its adjoint matrix, then we get a diagonal matrix with the diagonal entries as determinant. So hope you understand what is the relation between these two matrices. This is one of the simplest method to do the matrix multiplication. Now we study how to do the matrix multiplication of different order matrices. Now let's take this example. So first of all, we start with the first row. We write first row 2 minus 1 3. Now we multiply 2 with the 1, we get 2. We multiply minus 1 with the 3, we get minus 3. And we multiply 3 with the 2, we get 6. So it is similar to the previous one. The previous one is the basic method to multiplication. Now we multiply with the second column, we get minus 2, minus 4 and 3 into 1 is 3. Now we consider the second row. Now when we consider the second row, we have to multiply the second row with the first column. So we multiply 4 with the 1. So what we get? Yes, you are right, it is 4. We multiply 5 with the 3, we get 15. We multiply 2 with the 2, we get 4. Similarly, we multiply with the second column, so we get minus 4. 5 into 4 we get 20 and 2 into 1 we get 2. Now the only thing is we need to simplify this. So for the first entry we get 5, second entry we get minus 3, third entry we get 23 and the fourth entry we get 18. So remember the resultant matrix is 2 by 2. Now let's study what will be the difference if you interchange the position of these matrices. What will be the resultant? So we consider the second matrix as a first and first as a second. Order of an matrices plays very important role in a matrix multiplication. So if we interchange the order of a matrices, what will be the resultant? Consider the first row 1 minus 1. We multiply first row with the first column. So we multiply 1 with the 2, we get 2. We multiply minus 1 with the 4, we get minus 4. Now we multiply with the second column 1 into minus 1, we get minus 1. Minus 1 into 5, we get minus 5. Now we multiply with the third column 1 into 3 is 3, minus 1 into 2 is minus 2. Now we consider the second row. Now the second row is 3, 4. So now we multiply the second row with the first column. So 3 into 2 we get 6, 4 into 4 we get 16. Now we multiply with the second column, we get minus 3 and 20. Now we multiply with the third column, so we get 9 plus 8. Now any guess about the next step? Yes, we multiply the third row with the first column. So we write 2 and 1. So 2 2s are 4 plus 4. 1 into 4 is 4. Now the second column. So 2 into minus 1 is minus 2. 1 into 5 is 5. Now the last column. 2 into 3 we get 6. 1 into 2 we get 2. So if you observe, here we get a 3 by 3 matrices. Now simplify this. So by simplifying this, we get a resultant matrix as 2 minus 4 is nothing but minus 2, minus 1 minus 5 we get minus 6, 3 minus 2 we get 1. 6 plus 16 we get 22, minus 3 plus 20 we get 17, 9 plus 8 get 17, 4 plus 4 we get 8, minus 2 plus 5 we get 3, and 6 plus 2 is 8. Now, why the resultant matrices is of 3 by 3 order? So, if you observe, our first matrix having a number of rows are 3 and our second matrix having number of columns are 3. So, the resultant matrix is depend upon number of rows of the first matrix and number of columns of the second matrix. Remember this very important result. If you understood this, we already discussed about what will be the resultant if we interchange the order of the matrices. Now let's study the previous example. In the previous example, there is 2 row in the first matrices and 2 column in the second matrices. So therefore, our resultant matrix is of 2 by 2 form. Now let's go to the last topic, that is we multiply these two matrices. So obviously first of all we consider the first row, we write 2, minus 1 and 3. So here we multiply 2 with the 1, minus 1 with the 3. So there is no any single element to multiply with the 3. So whether it is possible the matrix multiplication? So obviously the not, because there is no any single entry to multiply the last entry of that first row. So here the matrix multiplication is not possible. So what is the basic reason that the matrix multiplication is not possible? So if you observe, there are 3 columns in the first matrices and 2 rows in the second matrices. Now remember this very important result. If number of columns in the first matrix is equal to the number of rows in the second matrix, then only the matrix multiplication is possible. So hope you understand what is a matrix multiplication, what is the effect of change of order in a matrix multiplication, and why the matrix multiplication is not possible. I guaranteed that you get 100% knowledge about the matrix multiplication. Thank you for subscribe channel. If you are not yet subscribed, please subscribe to get update about the new videos.